Welcome to the material session of Pulsar's Career Point. This is a video for the student of class 12 on Unit 2. The name of the unit is Electrochemistry. This is the part 5 video of this unit covering the topics electrical conductivity and different types of conductance. आम इलेक्ट्रोलिसिस कथा पढ़ी लॉज ऑफ इलेक्ट्रोलिसिस कथा पढ़ी ए वीडियो रे आम इलेक्ट्रिकल कंडक्टिविटी कथा पढ़ू the different factors influencing the electrical conductivity and the different types of conductance like specific conductance, equivalent conductance, molar conductance, etc. Now, let us come to know what are the factors affecting the electrical conductivity of the electrolytic solution. Inter-ionic attraction or solute-solute interaction. यदि सॉल्यूट सॉल्यूट भितर इंटरेक्शन अधिक हुए तारे इलेक्ट्रिकल कंडक्टिविटी लो हम हायर द इंटरआयनिक अट्रैक्शन दैट इज सॉल्यूट सॉल्यूट इंटरेक्शन लोअर विल बी द डिग्री ऑफ आयोनाइजेशन. नाउ कम टू द सेकेंड फैक्टर दैट इज सॉल्यूशन ऑफ आयन्स और सॉल्यूट सॉल्वेंट इंटरेक्शन. यदि सॉल्यूट और सॉल्वेंट भितर इंटरेक्शन अधिक हुए ताले इलेक्ट्रिकल कंडक्टिविटी हाई हो. Higher the solutions of ions or solute solvent interaction, higher will be the degree of ionization. आम गोटे solute solute interaction था पढ़ले solute solvent interaction कथा डिस्कशन कले एबे देखिबा जे solvent solvent भितर interaction अधिक हुए then what happens to it. Now third factors viscosity of solvents or solvent solvent interaction. Higher the viscosity of solvent or solvent-solvent interactions, lower will be the degree of ionization. Hence, the lower will be the conductivity. ताले तीनटा कथा हमें देखिले solute-solute interaction ने मध्य higher the solute-solute interaction, lower will be the degree of ionization. Higher the solute-solvent interaction, higher will be the degree of ionization. Higher the solvent-solvent interaction, lower will be the degree of ionization. ଏବେ temperature କଥା ଦେଖିବା. With rise in temperature, all the above three factors decreases. Solute-solute interaction हो, solvent-solvent interaction हो, बा solute-solvent interaction हो. Temperature बढ़िबा संगको ये तीनोटी जाक factor decrease करे. Thus, the average kinetic energy of the ions of the electrolyte increases with rise in temperature. As a result, the conductance of the electrolytic solutions increases with increase in temperature. Temperature बढ़िले electrical conductivity of the solutions, the conductance of the electrolytic solution increase करे due to increase in the kinetic energy of the ions of the electrolyte. As it kinetic energy increases with rise in temperature. ताले में चारोटी फैक्टर कथा देखिलु. Solute solute interaction हेले higher the solute solute interaction, lower will be the degree of ionization. Higher the solvent solvent interaction, lower will be the degree of ionization. Higher the solute solvent interaction, higher will be the degree of ionization. Our temperature increase कले कौन होबो ना conductance of the electrolytic solutions मध्य increase करिवो. एबे देखिबा resistance R and specific resistance rho. What do we mean by resistance? It is observed that for any conductor, the resistance R is directly proportional to its length. That is, R is proportional to L. Let it be equation 1. Again, the resistance R is inversely proportional to the area of cross section. That is, R varies 1 by A. Let it be equation 2. Now, combining equation 1 and 2, we get R varies L by A. Implies R is equal to rho into L by A. Let it be equation 3. Now, what is rho? Where rho is the proportionality constant called as specific resistance. Its value depends upon the nature of the material. Now, by taking from equation 3, we get rho is equal to R into A by L. By taking the reciprocal of equation 4, we get एटी रेजिस्टेंस कथा पढ़ुथु तेणु आर काटिदेलु आर इज रो यूनिट केते रहइबो ना यूनिट्स ऑफ रेजिस्टेंस इज ओम स्पेसिफिक रेजिस्टेंस रो यूनिट हला ओम सेंटीमीटर और सेंटीमीटर इनवर्स बिकॉज रो इज इक्वल टू r into l by a by l so ओम सेंटीमीटर और ओम मीटर भी कहा जाए परिवेश साइज सिस्टम now conductance and specific conductance the reciprocal of resistance is called the conductance it is represented by the symbol c we know that r is equal to rho into l by a here rho is the specific resistance l is the length of the conductance a is the area of cross section. Now by taking the reciprocal of equation 1 we get 1 by r is equal to 1 by rho into a by l. Again 1 by r is equal to c because reciprocal of resistance is conductance. 1 by rho reciprocal of specific resistance is called specific conductance that is k kappa. So c is equal to k into a by l where k that is kappa is equal to 1 by rho. By rearranging this equation for k we get k is equal to c into l by a that is the specific conductance is equal to observed conductance into cell constant. L by A is known as cell constant. The factor L by A is known as cell constant and is expressed in the unit centimeter inverse. Now, let us compare what do we mean by specific conductance? So, specific conductance is the conductance of 1 centimeter cube of a solution of an electrolyte between the electrode exactly 1 centimeter apart. It is denoted by the symbol K that is kappa where K is equal to 1 by rho. Unit is equal to 1 by ohm centimeter that is ohm inverse centimeter inverse in CGS system and in SI system it is ohm inverse meter inverse or you can write down mho meter inverse. This is the unit of specific conductance. Now let us compare the equivalent conductance lambda EQ. Definition: the conducting power of all ions produced by dissolving 1 gram equivalent electrolyte in solution is called the equivalent conductance. It is represented by the symbol lambda EQ or simply lambda. 1 gram equivalent of electrolyte. What do you mean by 1 gram equivalent of electrolyte? 1 gram equivalent of an electrolyte is the amount of it which on dissociation in solution gives a total of 1 mole of positive and 1 mole of negative ions. सेतिकी amount of electrolyte जेमुडिको dissociation हला परे 1 mole of positive ion एवं 1 mole of negative ions देई थांती हमें सही क्वांटिटी of electrolyte को कहबा 1 gram equivalent of the electrolyte. Now, if V is the volume of the solution in cubic centimeter containing 1 gram equivalent of the electrolyte, then equivalent conductance is equal to specific conductance into V. Then lambda is equal to K into V. If C gram equivalent of the electrolyte is present in 1 liter of solution, then V is equal to 1000 by C. So lambda is equal to K into 1000 by C. In terms of normality, the above equation can also be written as lambda is equal to K into 1000 by N. These three equations are the relationship between equivalent conductance and specific conductance of the electrolyte. Now, unit of the equivalent conductance, ohm inverse, centimeter inverse, gram equivalent inverse, or we can write down mho centimeter square gram equivalent inverse. In CGS system, in SI system, it is ohm inverse, meter square, gram equivalent inverse. These are the units of equivalent conductance in CGS system and SI system. Now, molar conductance, lambda M. What do you mean by molar conductance? The conducting power of all ions produced by dissolving 1 gram mole of electrolyte in solution is called molar conductance. It is represented by the symbol lambda M. If Vm is the volume containing 1 gram mole of the electrolyte, then molar conductance is equal to specific conductance into Vm. If cm gram moles of electrolyte is present in 1 liter of solution, then Vm is equal to 1000 by Cm. So molar conductor lambda m is also written as lambda m is equal to K into 1000 by Cm. In terms of molarity, it also can be written as lambda m is equal to K into 1000 by M. These three equations are the relationship between molar conductance and specific conductance. Unit of molar conductance, ohm inverse centimeter square, gram mole inverse in CJ system, and ohm inverse meter square, gram mole inverse in SI system. Thanks for watching Gopal Sir's Career Point. Please like and share this video. Don't forget to subscribe my channel if you are watching it for the first time.